Welcome back to 5-Minute Chemistry. Today we are going to continue our little detour into the realms of physics to discuss how energy can be transformed from one form to another, more specifically from potential energy to kinetic energy and then back to potential energy. And we will also talk about how we can plot the energy changes in a system. So when it comes to transforming energy, let's take a look at this example. So you have a ball in a bowl up there, so it is not moving yet, so its kinetic energy is 0. For potential energy, we actually don't have an absolute scale. We have to define our 0, so we can define it to have a 0 potential energy, so total energy, which is kinetic energy plus potential energy, will also be 0 here. As the ball starts rolling down here, it is gaining speed, it is gaining kinetic energy, so kinetic energy goes up, but it is also moving downwards, so it is losing potential energy, but the total energy will stay the same. And as it moves down to the lowest point in this ball, it will reach the maximum of its kinetic energy and the lowest in its potential energy. And as it starts to climb up, it will convert its kinetic energy back to potential energy as it's moving upwards. The speed is going down, and it reaches the highest point where the kinetic energy is back to 0 and its potential energy is also back to 0. So if you use this kind of standard, your potential energy is going to be negative here, and then kinetic energy is between 0 and some positive value. And of course, this is only true if you do not lose energy to your surroundings. So if you don't lose any energy to your surroundings, then your total energy cannot change due to the conservation of energy. But in real life, of course, when we talk about balls, there is air resistance, so some of your energy will be converted to heat and will be transferred to the air, and you can lose energy that way. So if we draw energy like this, we can have energy diagrams. So in this case, we have a potential energy diagram for this mountain, and as you go from here up to the mountain, your potential energy is increased, so we can have some kind of scale on this potential energy diagram. We can define where the 0 is, and if we go higher than that, we have positive potential energy, and if we go down, then we will have negative potential energy, something like this. And we can use a similar diagram to show total energy. So this energy diagram here shows the gravitational potential energy around the Sun and the orbit of a planet like Earth. And this yellow line here is symbolizing the total energy of the Earth. Well, Earth is not falling into the Sun during its orbit, but there are times when it's closer to the Sun. So I think in December, Earth is closer to the Sun, and then in June, July, Earth is farther from the Sun. And when the Earth is farther from the Sun, then the potential energy is higher than when it is closer. So of course, when the Earth is closer to the Sun, lower potential energy, but same total energy means the kinetic energy will be larger. So basically this distance here between the potential energy and the total energy is going to be the kinetic energy. And this is also here because during the orbit, Earth's total energy is not really changing. And as Earth moves closer to the Sun, it speeds up and gains a higher kinetic energy while decreasing the potential energy. And when the Earth is farther away from the Sun, it is gaining potential energy, and therefore the kinetic energy goes down and the speed of the orbit decreases. So for chemical processes or even physical processes like phase changes, we can draw these kind of energy diagrams. So we might say that in the beginning we have liquid water here. So this is liquid, and then we boil this water, it evaporates and becomes gas, and gas has a higher energy than liquid, and then this gas can condensate and freeze, and so we can get ice from it, and the ice will have a lower energy than both the liquid and the gas. So we can draw this kind of processes in terms of the energy that material is carrying. And this can help us explain a lot of chemical processes also. Okay, so this is it for today, and I will see you tomorrow.